Now this illustration illustrates enclosing same-size conductors in accordance with a table is listed in C.1 through C.20, I believe it is, in the Annex C. But notice here we're using rigid metal conduit, and we have 4 number 6s that we're pulling through that rigid metal conduit. Now, electricians, if they know what they're doing, they look at the conduit run. How many 9s you have in it? You'd say, well, I got 2. How many offsets that you may have in a conduit? We used to have 2 45s. So you'd add those together, and then would you want to make the conduit maybe one size larger so that the conductors would pull easy? More especially if you're using the maximum size number of conductors that you could pull through the raceway. Now I'm going to do this a little differently this time. We're going to look at the problem first and see what the question is. And the question is basically what size rigid metal conduit is required to enclose 4 number 6 AWG THWN copper conductors. Now notice if they're the same size, we can review our note 1 to table 1 to chapter 9, and if the conductors are the same size, then it's recommended that we could go over to the Annex C. But remember, using the Annex C is up to the authority having jurisdiction, because the annexes are not mandatory rules. They are recommended rules. But we are actually recommended to use that. And when you're dealing with conduits, raceways, and things of that manner, first of all, you ask yourself, what is a raceway? What is a raceway? Well, it's over 2 foot long. Terminates end to end. What is a nipple? It's 24 inches in length or less. Terminates end to end. What is a sleeve? Well, a sleeve is open on both ends, and it's used to protect a cable, PVC, or any other wiring method you want to use. Usually they're 10 foot or less in length, 300.10. The exception there, I believe it's 2, tells us that the short lengths, and the authority having jurisdiction says a short length is a regular stalk of conduit that's cut to the length that is needed. Now, that's considered a sleeve, and so you got to know what you're dealing with. If it's are you an auxiliary gutter or a wireway? How do you determine that? Well, we'll get into that. But an auxiliary gutter will supplement switches and things below. But if you had a switch to the right of an auxiliary gutter, and from that switch you extend it out over 30 foot, then it's classified a wireway in accordance with 366.12, item 2. If it's a sleeve, you go to 300.10, and I believe it's exception 2. If it's a raceway or nipple, you have to go to note 4 and note 1 to table 1 to chapter 9 to determine that. And if you're, say, on a construction site, you're performing maintenance, remodeling of some sort, repairing, I could take a flexible cord and run it through rigid metal conduit coupled together up to 50 foot. Schedule 80, something that's durable. As long as it's above ground, I could run that flexible cord through it, and then if that is a thoroughway, active area, the cord is protected, but you'd have to go to 400.5A of the code to get that permission. So you see, you got to determine, is it a raceway or is it a nipple? Could be a sleeve, could be an auxiliary gutter, might be a wireway. Now, we'll get into this in a little bit more detail, but notice the step 1. I'm using the table C as in car 8 in the Annex C. Now, at the beginning of the Annex C, you have a table that lists all your wiring methods and the page that they are on in the Annex C. Keep that in mind. It's right at the front of the Annex C. And you could find out exactly where rigid metal conduit, what page it's on. Then you could see and select your rigid metal conduit based upon 4 number 6s, and it'd be a size of 3/4 minimum. Have you ever tried to pull 4 number 6s through 3/4? Better be a straight run. So you might want to upsize that to a 1-inch. Then you have more room. And that'd be where, you had 90s. Remember, you can have 4 90-degree bends in a raceway. And then you could have a conduit body, pull box, junction box, and start all over again. Just pulling the wire to that through that box and routing it on, see. But you have to break that run of conduit with a junction box, pull box, octagon box, square box, device box, whatever it may be. Now, so the solution and answer, it would take a 3/4 rigid metal conduit to enclose 4 number 6s. Now, the quick count says, Table 4, Chapter 9, if you have over 2 conductors, 40% fill from that table. If you looked at 100% fill of a 3/4 inch, it's 0.220. Table 5, Chapter 9 says a number 6 has a square inch area of 0.0507. Now, take 0.220 from the 100% fill column in the Table 5 for rigid metal conduit and do your math, and notice you come up with 4.339. So you could actually pull 4 of those number 6s through 3/4 inch conduit where the distance and so forth would allow you to do that without damaging the installation. So this illustration shows the step 1 and the solution based upon the number of conductors in the conduit, how to select the size conduit using the Annex C. But the quick calc shows you that, yes, when I run the quick calc is shown there, I know that 3/4 inch conduit will house the 4. Now, we're not saying or telling you that you have to run that quick calc. You can just do the one at the top and determine what size conduit you would need minimum, and then you determine if you needed to increase it in size due to 90-degree bends and offsets and things like that. Now, that's what this illustration is illustrating to us. Enclosing the same conductors in accordance with the table that you choose based upon the raceway type from table C.1 through C.20 really is what we would go look at in the Annex C. And keep in mind, you can get lost in those tables if you're not familiar with them. So always turn to the very front of the Annex C. Select the wiring method that you're going to use, and it'll send you to the page where that system of values will be shown for the number of conductors and the size conduit you would need to select.